Hi everyone, this is Evgeny and I welcome you in our LangGraph Introduction series. In previous videos, we checked what the human in the loop is, and we've been working with setting breakpoints, resuming the graph, updating the states. And this time we'll try to take a deeper look and maybe learn about something about the theory behind all that. And quick note, there is a link to Amazon website in the description, so please click on it, and then when you buy something somewhere, Amazon will reward me and provide a couple of cents, so I will be closer to my dream, a new keyboard. Alright, thanks a lot, and now let's jump into the coding session. So today we are going about state, about checkpoints, about all this stuff, and for doing that let's first redefine our financial advisor graph with the one with the intent checker we created in previous session. So I'm just redefining this guy, and here how it looks like. We have an intent checker and we are forbidden asking questions that are not related to financial area. And again, if this is something really new to you and this is the first video you found on the internet and YouTube, then please check the previous videos where we are going deeper in the details of how to do all this stuff. Because this is a continuation, right? This is the video number 12 actually. Anyway, so we have a graph and let's run it. So we define it as thread, and we have a human message which is about weather, which is not financial advice at all. And we just stream in our graph and pre-printing the messages. And very expectedly, the graph was stopped at intent checker because this question is not a financial one. And just to prove that, let me print out the graph state. And this is pretty simple. It's from previous lessons as well. We have a thread. We are asking for get state. And we can see that the next node in the process would be intent check, so it's stopped here. And also we have a state which contains a list of messages, which has some metadata like configuration, checkpoint ID. We will be talking about that in details today. Some tasks. We do have this interruption. This is from us actually, right? There's please ask a question related to financial advice, and everything works as previously. But let's try and check what we have behind the scene, right? What's under the hood here. And this is how it looks like. So if you check at the left hand side, we have our graph. It's just a visual representation of it, right? We have intent checker, we have assistant, we have tools, and the cycling here is possible. And we are working in a thread, in the scope of a single thread. So in the scope of this thread, and we have a memory, and this means that we are saving the graph state. And in practice, what's happening, we do have on every node we have checkpoints. So on every checkpoint, when we are on a node, we are saving some relevant information, like we are saving the graph state, we are saving metadata, and all this kind of stuff. And what's happening when you call the graph get state, like for example here we stopped at intent checker, we are here, right? So when we call graph get state, we grab the the checkpoint here, the green one, and it has this state snapshot type, right? So when we get, again, just to repeat it, when we get state, it's here we have this snapshot of the checkpoint 1, and this is how it works. So in general, if we continue the execution, then the next checkpoint will be generated and it has its own state snapshot. And if tooling is called, then we have the yellow one here as well. It could be several one, and in the cycle it can be like forever, right? So this is the general idea how it works behind the scenes. And let's finish the graph. So we have the full state. So this time, what's happening? I'm starting a new thread, number 2, and I'm asking the financial question. And for simplicity, I will be only asking for stock symbol, so we don't wait for making another internet call, network call for some financial data, right? For us, it would be just enough if we grab the stock symbol from the single tool, and that's it. So I'm running it, and what we have here, the set of messages, the human message, then the next node, this was assistant. We have what's stock symbol for Tesla, then it was a tool call, the real tool call happened, we have this TSLA, and the final response we have that the stock symbol for Tesla is TSLA, right? And if I check this again, the current state of a graph, just to show you that, we don't have any next node, and we have the final state snapshot, which is pretty big and contains all the messages. So this one which we have, it's from somewhere at the beginning, right? Because the graph finished here. And another thing, like this represents the idea what happened just previously here. We went through the whole graph, and then so we have a thread and we have multiple checkpoints. Like for example, we had checkpoint 1 for intent checker, and we have state snapshot, we have the checkpoint 2 for assistant, then it was a tool call, for example, right? It goes to the checkpoint 3, and then it goes back to assistant, then we have checkpoint 4, and then maybe another tool call, checkpoint 5, then goes to assistance again, we have checkpoint 6, and then everything is finished. So what happens now, if we make a call for graph get state, we would grab the latest state of the graph, which is this one. But still, there is a possibility to check all the states at the same time. And for that, we have this get state history, which gives us back the list of all state snapshots that we went through across the execution of the graph. And well, let's give it a try, right? So I have this get state history, and we're not going because it's really a lot of information. We would have the list of these kind of objects. Let's just demonstrate that it's really multiple, it's a list. And see, we have already 6, right? 6 different snapshots. So what else can we do here? In general, I'm going to talk about replay. It's possible to trigger the execution from specific checkpoint. For example, for debugging purposes, or maybe your application needs that, you can trigger the execution of the graph from a specific checkpoint. And this is called as replay. So how we should do this? We have all the states collected from the previous execution, right? I'm grabbing this specific state, which is already after intent checker. So it's somewhere here, right? And just to double check it, the next node is assistant. So I'm somewhere in the middle of the execution, kind of. And what's interesting, I'm talking about checkpoints all the time, and this is the interesting concept because we have a thread ID, which is 2, it's clear, and then we do have this checkpoint ID, which is unique representation of specific checkpoint here. So why do we need that? It's pretty simple, because we can again resume the graph execution, but this time we are not providing the thread ID as previously, but we are providing this configuration object from our to replay state node checkpoint, this one. And this would force the graph to replay, meaning to repeat all the steps from specific place. So if I run it, and you can see it's here, right? It's the single symbol for Tesla message. We do have the tool call. The tool call gives us back something, and then the assistant generated the message. And practically this execution was very fast, because there is no, this is a very important concept, there is no real execution happens, because LangGraph knows that this checkpoint ID was already executed once, and it knows already the result of that because we are keeping all the checkpoints here. So what's happening, LangGraph just passes through the graph and providing all these checkpoints as a state. So no real execution. This is a very crucial concept, you need to remember about that. Let's try and change something. And this is called forking, and I was demonstrated last time in the studio already. I was forking the state, and in a nutshell what's happening here, it's pretty simple again. It's a logical thing. You have a checkpoint, and if you update it here, then another checkpoint will be created which has its own state snapshot, for example, and then if you try to resume a graph, like this is the first one, this is the second one, the LangGraph knows, okay, this checkpoint was never executed, so it would start the real execution from this point. And let's demonstrate it using the SDK, right? So again, I have all the states, I'm forking my value, my checkpoint here, and I'm grabbing this one, and what is the stock symbol for Tesla. And again, we have the next node would be assistant, and we have the configuration for this checkpoint with specific checkpoint ID. And this is really crucial because this is how LangGraph knows if something was executed or not, and it helps to distinguish between different checkpoints. And now let's update this checkpoint. So we are doing this update state. And again, we are not providing this red ID as previously, but we are providing this checkpoint configuration, which has this red ID and checkpoint ID. And we are setting our state, so messages. We are adding the human message with the content, what is the stock symbol for NVIDIA, not Tesla anymore. And again, we have this trick, right? Because in general, here we have a reducer, and the default behavior of this reducer is adding on the top. And to override this behavior, we are providing for the human message, we are providing the ID, which is exactly ID of this message. So it's this one. And we put it here, right? And so what's happening in this case, we already talked about that in the past. If the message with this ID already exists in the list, then this reducer would replace the message itself, right? And back from the graph update, we have this configuration. And if you check it, it's practically the different, so it's the same thread, 2, and it's different checkpoint ID, right? This one and that one. So what happened, practically another checkpoint was created here. And if you run it, maybe I just do it here. So this is the updated state, right? We grabbed the last state from the graph, and this time is this one. And if you check, we do have the next node as assistant, so it's not in the beginning, but the message itself was already updated. It was containing this NVIDIA. And if you resume it as previously, as I was saying this already, right? This checkpoint was never executed, which means that LangGraph was started in real time and process all the nodes here as expected, like assistant and tool calls and real network calls, and all these things will happen. So just to demonstrate it. And we do have this stock symbol for NVIDIA, and this is from assistant already, and we have a tool call, and this tool call, a real network call, was behind that, and it returned NVIDIA, and we do have the response here. And just to demonstrate that our graph was finished, the next state is empty because the graph finished till the end. And just for a quick demo, you can do exactly the same things using an API, right? Because this is your number one, practically, right? You're not working with SDK, it's more about using an API. And again, I'm copying the URL of the local server running on my machine. I'm enumerating all the assistants, and we will be working today with financial advisor intent check 1. And let's just try these two concepts using an API. So again, what we have here, we are creating a new thread. We have the human message for Tesla, and we run it just to see it till the end. And you can see the conversation, right? This was the symbol for Tesla from the intent checker. This one was one from our assistant. Then there was a tool call, which look out for stock symbol. Then the result of tool call was here, and then the assistant generated the proper message in response. So we have the graph finished. We have all the states kind of saved in the graph for specific thread, and we can do the same thing, right? We get the history, which gives us the list of all the states, and we grab a specific state somewhere next to the end. So we have 6 states again. And let's try and replay it. And this is -5, so it's pretty somewhere next to the finishing graph, right? What we are doing here, again, we are streaming the same technique, right? We are providing the thread ID, we are defining the assistant, which is financial advisor with intent checker. We are asking for resuming, so we are putting here none. And the new thing here, we are providing checkpoint ID. So we are asking to replay this graph starting from specific checkpoint ID. This one is to replay. The replay, it comes from here, it's somewhere. Checkpoint ID, it should be there, this one, right? So we are replaying the graph from this specific point, and then we're just printing messages. And you see, since we were replaying from the middle of the graph, it's already, we have the result of our tool call without any tool call need requests, right? And immediately it was the symbol for Tesla is TSLA. And this was replaying because, again, nothing really happened because all the states were already in memory, and LangGraph knew about that, so it just replayed it and showed us the result. So no real network calls. Please remember about that. And the last thing, let's check about forking. And again, we have a list of all the states, and we pick specific state, right? And it was, what is the stock symbol for Tesla? We need this because we would like to change the Tesla to another company. And it's assistant node, and just to demonstrate, there is a checkpoint ID for this specific state. And then we are forking, and we're doing this with update state. So the same technique, we are providing human message, what's the stock symbol for NVIDIA in this case, and we are providing specific message ID, so it's been replaced but not added on top. And the same thing here, we are doing this checkpoint ID thing, and we are pointing to a specific state we would like to update. And we're printing the result of this update. Right, and you can see that, for example, checkpoint ID is different. So the state was updated and a new one was created. And we can resume the graph. This is the forked version. The input is none. Let me just go quickly through it. Checkpoint ID, we have this forked config, which we just get back from the client after the state was updated. And we are asking to resume the work with the forked version. And we have the content was changed, and it's pretty longer. It's much more longer now because we do have the real network calls. And it was NVIDIA, and is expected the stock symbol for NVIDIA is NVDA. All right, that was kind of final video for human-in-the-loop concept. And just to quickly recap all the things, we went through the ways how you can interrupt the graph, how can you set the breakpoint, how can you resume the graph, and of course, how can you do something in the between. Like, for example, user can accept your message, or you can even modify the state, so grab some input from user. And it was me, Evgeny. Next time we will check some other things in LangGraph introduction series. So let's stay and keep in touch. Bye-bye.